Hello, Honest Statistics. Sorry, this video is really it's a long overdue. I apologize for that once again. Let's just get started right away. So for this question for the multiple choice, I believe that I did go over this question with you guys. If we're talking about the probability of B given A be given as the female. So we're choosing out of all the females the event that B will happen, which means the tortoise tortoise is a Moravka. So that is both female and Moravka, which means that's 15 out of the 48 tortoise that's actually female, which means the question here, if you actually type this up into your calculator, you're going to get about 0.313. That's 31.3%. But the answer here would be B, is because that is a probability that a randomly selected female tortoise is a Moravka. So we're choosing out of the female how many are Moravka, and that's pretty much what the question number one is talking about. Number two, also did this in the class. When we're talking about Samir rolling a six-sided die every morning, 2 out of 6 becomes a big breakfast, and 4 out of 6 becomes the little lighter breakfast. So that's about 0.33, and this is about 0.67. And with those probabilities in hand, so what's the chance that he will be late for school and not late for school? So this will be the chance that he will be late for school, not late for school, late for school, not late for school, like this. So if we're talking about cooks himself a big breakfast, there's a 15% chance. So we're talking about 15% chance here. That will leave 85% chance that Samir will not be late for school when he has the big breakfast. Now, if he has a lighter breakfast, 6% chance that he will be late for school. That leaves me with 94% chance that he will not be late for school. So if we're talking about what is the probability that Samir will be on time? Well, we're really talking about the not being late to school. We're really talking about these two events here. So with those two respective probabilities, I'm just going to multiply them. So let me just take my calculator out real quick. 0.33 times 0.85. Well, this will yield about 0.2805. And this other one, 0.67 times 0.94, you get 0.6298. So when you add these actually two together, you get about 91%, and that should be the correct answer for 2. Number 3, test for heartworm. This one also is a tree diagram question. You actually want to start reading from this because it says 10% of the dogs actually do contain heartworms. So which means heartworms here and not heartworm here, which means 10% here and 90% there. That's how you always want to start this question, is that do you have a solid like one category that tells you, hey, a certain percentage have this, that means the rest of them have that. And then with that, you can read this first part here that says, a test for heartworm in dogs show a positive result in 96% of dogs that actually has a heartworm. So it tests positive 96% of the time out of the dogs that actually do have heartworm. So this is how you want to set it up, which leaves me with 0.04, 4% of the time. People who do have heartworm, they actually test negative for this. Then you do testing positive or negative with people who, the dogs who do not have heartworms. That would be 98% of dogs with no heartworm. You're going to show a negative result. So that would be 0.98. This would leave me with 0.02. Now, the question is actually a little bit complicated because it's what is the probability that a randomly selected dog that tested positive for a heartworm, comma, let's say I put it there, which means we're given a conditional probability of out of the dogs that just showed positive, which means out of these two, how many do actually do have heartworm. So if we just take the 0.1 times 0.96, this would be 0.096, and 0.02 times 0.9, this would give me 0.018, which when you add these two up, 0.096, this will leave me with 0.114. Those are the dogs that actually tested positive. Now, out of those, we're talking about how many dogs that actually do have heartworm out of the ones that actually tested positive. Well, the probability of both of them happening at the same time, because remember, that is HN positive over just positive. We just written down the probability of positive there, which is just these two things added together. The probability that the dog actually do have heartworm and actually test positive, well, that's just 0.096. So 0.096 out of that entire answer, that will give me about 84% as the result. All right, number 4, when a patient complains to a doctor about a certain set of symptoms, I believe I made a typo there. There should be condition B 70% of the time. A patient with these symptoms that is not diagnosed with condition A diagnosed with condition B 10% of the time. Again, we're talking about A and not A. Then you have condition B, not condition B for both of those branches as well. So it says that if a patient with these symptoms is diagnosed with condition A, he or she is diagnosed with condition B 70% of the time. So that is this. In the very beginning, it says the doctor diagnoses the patient with condition A 15% of the time. So out of 15% out of the all patients, the doctor says, hey, you have a condition A, that's 15% of the time. That leaves me with 85%. Remember, they all always have to add up to 100. So then out of the people who do have condition A, he or she is diagnosed with condition B 70% of the time. That's where I wrote down the 0.70. 0.30 down here, a patient with these symptoms that is not diagnosed, condition B 10% of the time, and that will leave me with 90% here. So then what I want to do is, what is the probability that a patient with these set of symptoms will be diagnosed with at least one of these conditions? Well, at least one of these conditions means either you have A, or you have B, or you have A and B, all those three. What you do not want is neither of those two, basically. So we basically want to eliminate this branch. This branch counts because at least one of the conditions is present. This branch also counts because A is still present. This branch counts because the B is present. So we're really looking for these three probabilities and not counting the last one, particularly because none of the two conditions are present there. So 0.7 times 0.15, that will leave me with 0.105. 0.15 times 0.3, that will leave me with 0.045. 0.85 times 0.1, that will leave me with 0.085. And so when you just add all of these probabilities up, you get 0.235 as the result. And that's pretty much it. 5 says, what is the probability that first two randomly selected bosses contain Serenity and Black Star? Well, Serenity and then Black Star, with these two, you want to make sure that Serenity and Black Star and vice versa, you want to count for both of those. So the first option is Serenity, which is 0.12. Then you can have Black Star, which is 0.18. So you can multiply those two things together, or you can have Black Star and then Serenity, which is 0.18, then 0.12. Basically, what you're doing is you're doing the same multiplication twice. And then, so you're doing this and doing that, and basically you're adding those two together up, which will leave me with 0.0432, because what I get is 0.0216 for both of these, and you can just simply add those two things up and voila, off you go. Suppose P of X is 0.35 and P of Y is 0.4. If P of X given Y is 0.28, what is P of Y given X? Please note that during your test, you must know the conditional probability. This is X and Y given probability of Y here. Well, I'm given probability of Y as 0.40. Remember, the second thing always goes down here. The probability of X and Y, therefore, is something that is unknown, but they also tell you that this entire probability is actually equal to 0.28. So what I can say is the probability of X and Y is 0.28 times 0.4, because if you take this from the algebraic standpoint, I mean, how would you get this question mark by itself? You are going to simply take 0.4 and multiply it to both sides. So you can actually get this question mark by itself, which turns out to be probability of X and Y. So then it's 0.28 times 0.4. And then with this, I can actually solve for this, which I can say it's probability of Y and X given probability of X, because that's the second component. Well, since we already know that the probability of X and Y is 0.28 times 0.40, just because I have X and then Y doesn't change the fact if I have Y and then X, it's going to give you the same thing, because we're talking about X and Y. Me and you is same as you and I. And then over probability of X, which is 0.35. So this will be your final answer, which is the same thing as saying B for this one. Number 7, the probability that there will be an accident on the Highway 48 depends not on the weather. If the weather is dry that day, there's a 2% chance, a 0.2% chance of an accident on Highway 48. If the weather is wet, then there is a 1% chance. Today, the weather station said there is a 20% chance of the weather being wet. So let's say wet and dry, 0.2, 0.8. Then they said that there's a 2.2% chance that you have an accident when it's dry. So to have accident or not to have an accident, that's the question. If it's 0.2%, that's 0.002, which leaves me with 0.998 chance that there will not be an accident on a very dry day. Now for wet, it's a little bit different because now you have a 1% chance. That's 0.01 in terms of decimal, which leaves you a 0.99 for the wet days to not have accident. What is the probability that there will be an accident? Well, we're talking about these two branches, the one with the accident present. So 0.01 times 0.2, that will be 0.002. 0.002 times 0.8, that will be 0.0. I believe it will be 0.016 if I'm not mistaken. Let me just verify. Yep, 0.0016. And you're just going to simply add these up and say D because that sum up 0.0036 is present afterwards. Number 8, the probability that Ted enrolls in an English class is 1 out of 3. If he does enroll in an English class, the probability that he enrolls in a mathematics class is 1 out of 5. If he does not enroll in English class, the probability that he enrolls in a mathematics class is 3 out of 5, which means to take English or to not take English, to take math, not to take math, another tree diagram question. So if I have all the probabilities in fractions, all you really have to worry about is then converting it to decimals and solving it that way, or you can just simply subtract it from 1. So if 1 out of 3 takes English, that means 2 out of 3, the other, does not take English. 1 out of 5 takes math if you do take English. So 4/5 do not take math, 3/5 take math, 2/5 does not take math. So this will be your tree diagram for number 8. What is we learned that Ted enrolled in a mathematics class, comma, what does that mean? It means that it's given a condition that, hey, Ted did enroll in mathematics class. So guess what? We need to figure out the probability for these. If you just type in 1 out of 3 times 1/5, you will get a decimal point equivalency of 1 out of 15. So let me just type that in for you guys real quick. So I get about 0.06667. And then that is 6 out of 15. So if I convert that into decimal, it'll be 0.4 for this one here as well. When you add them up, obviously the probability of math will be 0.4667, it seems like. Now what I want to do is math. What is the probability he enrolled in an English class is math and English at the same time, which is simply just this, because that is math and English, 0.06667. So I'm just going to do 0.06667. So that divided by 0.466667, and then I end up with getting 0.142857-ish. So that will give me B for my final answer. Number 9, it says a dentist has noticed that about 2 children every 7 whom sees the professional development cavities before they turn 10 years old. Last week, he examined the teeth of 5 unrated children younger than 10. That explains the number of children who develop cavities before turning 10. Which of the following is a probability that at least one will develop a cavity before turning 10? So about 2 children every 7, that is your probability, which I will say is give or take roughly, just that's 0. I believe 28 something. Yeah, 2857. But quite honestly, you don't need to find a probability for this because it says that what is the probability of at least one will develop cavity before turning 10? You guys remember that at least one means that one or more. So probability of x equals 1, probability x equals 2, all the way to probability x equals to 10. That will be your probability that you want to solve for this whole entire thing. But how do I get the rest of, you're not going to sit there, solve for math for all of these different components. Rather, what you're going to do is you're going to solve for the probability of solving for none of them and subtract it from 1. Because like I said before, at least means take a look at what you're trying to find for the opposite and subtract it from 1, because that will be the quicker way to solve these types of questions. So the correct answer here is D. Because if I'm talking about at least one, the opposite of that will be having none of them, and you just subtract that from 1 and off you go. Number 10, a complex electronic device contains 3 components. The probability of failure for each component is these 3. If any one component fails, the device will fail. If the component fail independently from one another, what is the probability that the device will not fail? Device not being a failure means all of these are going to be successful. If the probability of failure is 0.01 for the first device, that means you have a 99% chance of success for the first one. That is 0.97, 0.96 respectively. And all I got to do is just multiply each of them. And I end up with 0.922. Why do I multiply them? Well, because they told me that they're independent of each other, which means that allows me to multiply the probabilities. What are you exactly multiplying and why does this matter? Well, these three things are the chances of each of those devices being successful. If you read carefully, it says if any one component, even a single component failing, you would be classified as a failure, which means all of these has to be successful in order for the device to be working smoothly. So the correct answer here is D. You just take a look at the probability of success for all of them, and then you just multiply them all. So I will upload this answer key for you guys up on Teams. Now let's take a look at this right here. The statistics here for probability of this. And I know that I gave you this for your I believe the FRQ. So for the very first question, it says, given that a randomly selected registered voter is a male, so out of 200, what is the probability that he's registered for party Y? I believe we all had this written for our free response review and when I went over this, they were just talking about male and we're talking about party of Y. Now, if we're looking at the probability notation, which I will not test you on, by the way, that will be male given, given male, how many belong in a group called party Y? That's the question. Part B, what is the probability that a selected political party register will not be from party X, which means not being part of party X means these two together, which is kind of the same thing as saying 500 minus 244. So I'm just going to say that's 256. So out of those, what is the probability that you're selecting those? Oh, I'm sorry. Out of 500, because we're talking about a selected political party register, that's about 256 chance that you're going to pick. How do you write the probability notation? I mean, that's the complement of X because not X simply means that. What is the probability that a person chosen a random from those sample will be in 31 through 45 category? Well, that's 89 out of 207. What is the probability that a person chosen at random from those sample whose incomes are over 50,000? So we're talking about out of 96 people, how many will be in this category? Well, that's 35. So moving on right away. I wanted to go to tree diagram questions. I mean, I know I went through a lot during the topics during the multiple choice, but I hope this extra supplement helps you understand, gives you a little bit more understanding of how these things work. Fails 20% of his students in the final. So fail, not fail. So 0.8. So after the final, he posed a student and asked how many of those students studied more than 3 hours. Of those who passed, 72% studied for it. So let's write S. Of those who failed the final, 31% said they failed. They studied for it. So not being successful or not successful, not being studying for it will be complement of S. That will leave me with 28. This will be leaving with 69. And then now a student studies means these two added together. I think it would be a good idea just to write all of this right here. So 0.2 times 0.72 will be 0.144. That's 0.28 times 0.4. 0.28 times 0.2, which is 0.056. 0.31 times 0.8, that will leave you with 0.248. Lastly, 0.69 times 0.8, that will leave me with 0.558. A student studies means these two together, like I told you before. So 2.248 plus 0.144, you get 0.392. If a student studies, he passes. So given the probability that student studies, which is 0.392, that's out of the part A, what is the chance that he passes? Well, that is simply just this, 0.248, because that's the part of studying, and this is that branch right there means that you did not fail. So that would be 0.248 out of 0.392, which gives me 0.6326 for part C. If a student doesn't study, he fails. So people who did not study is about 0.6, 14. and he fails, which means we're talking about this branch, 0.056. 0.056 out of 0.614. Well, that will give me about 0.0912. The reason why this is the number at the top is because the failure is, I believe, this one. So he fails and a student does not study. That is 0.056 out of the people who did not study. That was the condition. A student doesn't study. Doesn't study means these guys, so 0.614. If a student studies, he fails. So it's out of 0.392, the same thing as part C, but he fails, it says, which means it's this one. So studies, and so 0.144, which is the other one, 0.144 out of 0.392. And as you've noticed, 3673, this and this number should add up to 100 because they're talking about the same condition. One fails and one doesn't. If a student doesn't study, he passes. So that is out of 0.614, just like part E, but he passes, it says. So that will be 0.558 because passes and did not study. So 0.558 divided by 0.614, that will be about 0.9087. About 90% of the students did not study, but ended up passing. Another tree diagram, 4% people who spend time in the woods get Lyme disease. So about 96% do not get Lyme disease. Of the people who have Lyme disease, they have a positive rating about 97% of the time. People who do not have Lyme disease, it will test negative 0.92%, 92% of the time. So that will leave me with these numbers. And obviously, I'm going to find all those respective numbers here. Always make sure to multiply the probabilities together. 0.0388, 0.03 times 0.04, 0.0012, 0.08 times 0.96, 0.0768. Lastly, 0.92 times 0.96, 0.8832. Now I have all the numbers at my disposal. It's just my job to just take a look at these and then just write down the correct numbers for these. If the person gets a positive reading, it's these two together. So I'm just going to take the 0.0388, add it with 0.0768, and then I get 0.1156. The person gets a positive rating. There's a typo, right? So then I believe this should be about a negative reading for some reason. So the negative would be 0.0012 plus 0.8832. So that will be 0.8844. The person gets a positive reading and has a Lyme disease. So positive reading, but does have a Lyme disease. That's 0.0388 out of the people who actually gets a positive reading, which was this one. So that will be 0.0388 out of the people who did get a positive rating. Type that in your calculator, you get 0.335. The person gets a positive reading. He doesn't have a Lyme disease. So positive reading, like I said, 0.1156 out of the people who have positive reading does not have Lyme disease is 0.0768, I believe. So it's 0.0768 divided by 0.1156. That will give me about 66.4%. Again, adding these two up will give you a 1. Does have a negative reading. That's out of 0.8844, courtesy of part B. So I'm just going to write the same thing for part E and F. Gets a negative reading if gets a negative reading, he doesn't have Lyme disease, which means we are talking about this one right here. So 0.8832. And this will obviously get a negative reading. He has a Lyme disease, which would be 0.0012. So, you can just type that in your calculator, 0.8844. This would be about 90.998643. And this one will be 0.0012 divided by 0.8844. So 0.001357. Now you might be wondering how many decimal points you would want. My honest opinion about these is that if you just write like 3 decimal points rounded up or down, or usually rounded up, of course, that will be just fine for me. All right. Thank you guys so much. I hope this helps, and I'll see you guys tomorrow.